This is a video on finding absolute extrema. The question states, find the absolute extrema of f of x is equal to 10x over x squared plus 4 on the interval 1 to 3. So remember, absolute extrema happen either at the endpoints or at critical points. And we find critical points by taking the derivative and setting it equal to 0. So let's take the derivative. We have 10x over x squared plus 4, so I'm going to use the quotient rule. So we have low, x squared plus 4, times d high, the derivative of 10x is 10, minus high, 10x, times d low, the derivative of x squared plus 4 is 2x. Square the bottom, and away we go. So now I can factor out a 10 because I have a 10 in both terms. And I get 10 times x squared plus 4 minus 2x squared on the top. And then I can combine like terms, and I can also pull out a negative sign. And I get negative 10 times x squared minus 4. I can factor x squared minus 4 as a difference of squares and set it equal to 0 to get negative 10 times x minus 2 times x plus 2 over x squared plus 4 squared equals 0. The denominator isn't 0, so I don't get any critical points with an undefined derivative, but the numerator is equal to 0 when x is 2 and when x is negative 2. But since we're in the interval from 1 to 3, negative 2 is not in that interval, so I just get x equals 2 as my sole critical point in that interval. So now I'm going to draw a table. So now I will construct a table that contains the endpoints 1 and 3 and the critical point 2. So there's my x values. Let's find the f of x values. That means first plug in 1 into our original f of x. 10 times 1 over 1 squared plus 4 is 2. Now we plug in 2. 10 times 2 over 2 squared plus 4 is 2.5. And when I plugged in 3, I used a calculator, and I got approximately 2.3. So we're looking for the absolute extrema, so we want the minimum and the maximum. So 2 is the smallest among 2, 2.5, and 2.3, so the minimum is at 2, or 1, 2. And the maximum is the largest of these numbers, 2.5, so the maximum is at 2, 2.5. And I'm done with the problem.